Plastic-eating bacteria turns waste into vanilla flavoring. A tasty solution to our plastic waste problem. By T.B. Fuyu. The invention of plastic has been one of the most important cornerstones to raising our standard of living in the past century. However, the same qualities that make plastic so desirable to consumers, in particular, its very low cost and high durability, also make it a bane to the environment. This is why scientists across the world are busy researching sustainable solutions to our growing plastic litter problem, either at the source, i.e., finding biodegradable alternatives, or during waste treatment. One such effort focused on the latter. Researchers at the University of Edinburgh in Scotland devised an experimental method that converts treated polyethylene terephthalate PET, the lightweight plastic used to package everything from beverages to food, into vanillin, the primary ingredient extracted from vanilla beans that creates the characteristic taste and smell of vanilla. To do so, the researchers turned to the common E. coli bacteria, which is found virtually everywhere, including your lower intestines. They engineered a strain to consume terephthalic acid, a molecule derived from PET, and transform the substance in vanillin, through a series of chemical reactions. During one experiment, the E. coli turned a used plastic bottle into vanillin which should be fit for human consumption. Subsequent research will determine whether or not this plastic-derived vanilla compound is indeed safe to eat. This research is exciting because it could solve two problems in one go. Every year, people across the globe produce about 50 million tons of PET waste with important economic and environmental consequences. Whilst PET is one of the most easily recyclable plastics, most still ends up in landfills or, worse, the ocean. Meanwhile, people love vanilla. In 2018, global demand for vanillin was in excess of 37,000 tons. The compound is not only used in food but also in other industries from cosmetics to herbicides. Thus, using bacteria to convert a harmful waste into a valuable product is a fantastic one-two punch. In the future, the researchers in Scotland plan on performing further strain engineering, process optimization, and extend the pathway to other metabolites so they might turn plastic into useful compounds other than vanillin. This is the first example of using a biological system to upcycle plastic waste into a valuable industrial chemical, and this has very exciting implications for the circular economy. The results from our research have major implications for the field of plastic sustainability and demonstrate the power of synthetic biology to address real-world challenges, said study first author Joanna Sadler of the School of Biological Sciences at the University of Edinburgh. Our work challenges the perception of plastic being a problematic waste and instead demonstrates its use as a new carbon resource from which high-value products can be obtained, said Stephen Wallace, co-author of the new study and a researcher at the School of Biological Sciences at the University of Edinburgh. To watch more articles, books and news on video format, please subscribe to our channel. You can also suggest us some topics to talk about in the comments section. The link to the original article in the description.